Alright, in this video we're going to solve some linear equations. And what this just means is if I have an axis or if I have a coordinate graph or Cartesian plane, at some point the line, a straight line, will cross x, right? Just one time, which means in these type of equations we have x raised to the first power, so x will only have one solution. Okay, let's look at the first one. So in the first one, they tell us, well, x is equal to 7. So all I have to do is simply substitute 7 into the equation. And I get 14 plus 40, and that gives me 54. What about the next one? Well, for the next one, we have 5w plus 2x is equal to 20. Again, they give us the value of x. So now we need to calculate w. Simply substitute the 2 with the x. That's equal to 20. Then I get 5w plus 4 is equal to 20. I'm going to transfer from the left-hand side to the right-hand side, so the symbol flips from positive to negative. You can think about it this way: when we have the left-hand side and the right-hand side, whenever something goes from left to right, the symbol flips. When it goes from right to left, the symbol flips as well. Or you can follow the American way, which is just subtracting 4 on both sides. So this is going to give me 5w, 20 minus 4 is 16. So my final answer, and then I divide with my coefficient. So I'm going to leave my answer in the fraction form, which is w is equal to 15 over 5. What about the next one? Well, for the next one, we might be tempted to multiply the 5 into the parentheses. But what I can actually do is just divide this equation or this expression by 5, but then I need to divide 5 with every single expression, right? So if I divide with 5, these two cancel each other out, so I'm left with w minus 2. 5 can go into 10 twice, and 5 can go into 20 4 times. Now I need to group. I need to group my like terms, which means the terms that are the same. So let's think about this. When I have a combination of apples and oranges, okay, if I want to count my apples, I need to separate my apples and oranges. So I want to take my apples to the left side. I want to take my oranges to the right side. It would just make it easier to count, right? Now the same thing I'm going to do with these type of linear equations. So I'm going to transfer from left to right, so it becomes negative w. And I'm going to transfer from right to left, which becomes negative 2. Then I have negative 4 is equal to 3w. Divide with the coefficient of 3. Coefficient just means a number in front of a variable, right? It can actually be two variables too. So let's say we have x, y. So x is a coefficient of y, but y can also be a coefficient of x. So my final answer would then be w is equal to negative 3 over 4. Okay. Let's look at D. So in D, I can use a process that's known as cross multiplication. So why does that work? Well, if I want to divide both sides by 1 over 3, I need to actually multiply this with the reciprocal, meaning the opposite, right? So let's say, for instance, we take 6, we divide that by 1 over 3. Well, we know from basic fraction rules that I do not want to multiply with the fraction. So divide with the fraction. So the reciprocal occurs, which means the fraction gets flipped around. So then we're left with 18, right? So I'm going to cross multiply. This gives me 2x minus 4 is equal to 18. I'm going to transfer from left to right. It becomes 2x is equal to 22. And when I divide with 2, I get x is equal to 11. So how does this actually work in theory? Well, in theory, we have 11 multiply 2 over 2. So these two can cancel each other out. This is the exact same as 22 divided by 2. I just decided to expand the value. Ooh. This one, now the questions become a little bit more complex. But it's okay, we can do it. Okay, so step 1. I want to get rid of this 3, right? I can get rid of the 3 by transferring it to the opposite side. Becomes 7 minus 3. So now I'm left with 2 and minus 3 plus 4 divided by 5 is equal to 4. Now again, I'm going to use this cross multiplication method. Okay, after I use cross multiplication, I have 2 n over 3 plus 4 is equal to 20. Remember, 4 multiply 5, excuse me. Then what we're going to do is we're simply going to, we might be tempted again to multiply the 2 by using the distributive property. But I'm just going to simply divide this entire expression by 2, divide by 2. So we have n over 3 plus 4 is equal to 10. Now transfer from left to right. I have n over 3 is equal to 10 minus 4, which is 6. And then we can do cross multiplication again. So n is therefore equal to 18. So get the final one. Now the final one is going to be a little bit tricky, but we can do it. Okay. I quickly want to get a calculator. Right. Got my calculator. Let's see if you can figure out what to do first. Give you a little bit of time. Okay. I'm going to multiply to the opposite side, or transfer from the left-hand side to the right-hand side, and I get plus 4. That gives me 77. It's going to be a little bit repetitive, but it's okay. Okay, what do you think we'll do next? Well, next, we can simply divide both sides by, by 7. That then gives me 2, 3n minus 5 minus 8 over 6 plus 1 is equal to 11. What do I do next? Well, by now you should notice the pattern. I'm going to transfer from left to right. So that gives me 10 is equal to 2, 3n minus 8 over 6. And now I'm going to do a little bit of cross multiplication where I multiply the denominator with the numerator, or the denominator with this numerator. Then we are finally left with 2, 3n minus 5 minus 8 is equal to 60. Transfer from left to right, that becomes 68. 2, 3n minus 5 is equal to 68. How did I get that? Transfer from left to right gives me plus 8. Now, we can divide both sides by 2. That gives me 3n minus 5 is equal to 34. Transfer from left to right, plus 5. That gives me 3n is equal to 39. And we can divide both sides by 3. That gives me n is equal to 13. Sorry about the background noise. Okay, so how do we know if our answer is correct? Well, we can actually test this. We know we just calculated n, and n is equal to 13, right? So now, if I had to substitute n into my equation, I should find that this entire expression is equal to 73. Let's actually do it. So I'm going to say 2 multiply 13, excuse me. 13 minus 5, parentheses closed, minus 8 over 6 plus 1 minus 4. Plus 1, parentheses closed, minus 4. Now I'm going to type this in on a calculator. So give me 1 second. 7 parentheses 2 fraction 2 multiply 39, excuse me, minus 5 parentheses closed minus 8 over 6 plus 1 big parentheses closed minus 4. And I do in fact actually get 37. So now I know that if I find 37 by substituting n into the equation, I know that my left-hand side is in fact equal to my right-hand side. And when this is true, our equation is correct.